Let's find the area bounded by these two curves, e to the 2x and e to the x, and the lines 1 and 3. So we have a formula, right? We're going to say that the area is, or I'll write the general formula, from a to b of, f of x minus g of x dx. And remember, the f of x and the g of x, these are just general functions here. This f represents the top of the rectangle. The g represents the bottom of the rectangle. Now, the f is not necessarily this one, and the g is not necessarily this one. These are just general functions for the top and the bottom of the rectangle. It's up to us to determine which one of these, this one or this one, do we really want to be f and g. So we know that the f, this is the top of the rectangle, right? So this is the top, and g is the bottom. So the top of the rectangle is going to come from the upper curve, the bottom from the lower curve. So we need to decide which one of these curves lies above the other one. What about this one here? E to the 2x, does that lie above or below e to the x? Well, we do know this, right? These are both exponential growth functions. The coefficient of the x is the growth rate. So this growth, this function here has a 2. This is only a 1. This function is growing faster than this function. So this function is going to lie above this one. So I'm going to make a quick sketch of these. So, they both cross at 1, right? So here's just e to the x. And e to the 2x, that's going to grow more quickly. And we want to go between 1 and 3. All right, so let's draw in our representative rectangle. Oh, that blue doesn't show up too well. But this is the top. There's the top of the rectangle. Here's the bottom of the rectangle. And we can see that the top is coming from the e to the 2x curve, just as we expected or suspected, and the bottom's coming from the e to the x curve. Let's compute this area. I'll do it up here at the top. The area is going to go from, the integration go from 1 to 3 of, the top of the rectangle, that's the top curve, e to the 2x. Bottom of the rectangle is the lower curve, e to the x dx. And we know that the integral, antiderivative of e to the 2x is e to the 2x over 2, and then minus, now the derivative and the antiderivative of e to the x is just e to the x. And we're going between 1 and 3. Let's put these limits in. We'll get e to the, 2 times 3 over 2 minus e to the 3 minus, lower limit, e to the 2 times 1 over 2 minus e to the 1. So what are we left with here? It looks like e to the 6th over 2 minus e cubed minus e squared over 2 plus e, right? Plus with that right there. Now the directions in this problem tell us to approximate this solution. So I did this on my calculator, right? You can just type in e to the 6 divided by 2 and so on. And when I did that, I got 180.65.